Hey, mathematician here, and today I'm going to show you how to hide part of a curve using complex numbers. The most famous example of this is probably the Batman curve. Here it is here. It looks really complicated, and it kind of is, but I promise by the end of this it should make a lot more sense. The curve's made by hiding different parts of curves and combines together to make the logo. I'm going to use Graph to demonstrate how to do this. It's just a standard graphing software on every Mac. First of all, let's have a look at y equals x divided by x, which is simply 1, because any number divided by itself is just 1. Now, what if we look at the absolute value of x divided by x? Well, now I can see that when x is less than 0, it becomes negative. This is because the absolute value takes the positive of any number, which means a positive over a negative, which will simply result in a negative number. So what happens when we take the square root of this? The square root of 1 is just 1, so that remains the same. But the square root of minus 1, that's I. And that can't be seen on the Cartesian plane, so it's hidden. We can extrapolate this a bit further by saying x minus a, for example, and then any value of x that's less than a will be hidden. Let's have a look at a equals 1. When x is less than 1, say 0, it becomes the square root of 1 divided by minus 1, which is the square root of minus 1, and is hidden. And that applies to any value less than 1. Let's have a different look at this. What if we say a minus x? Well, this will mean that if x is greater than a, that it will become hidden and complex. Well, we can combine these two things and say that for x minus a and say b minus x, we could set the bounds between x, which is greater than a, but less than b. I'll just finish writing this up here, and then we'll have a look at an example of x, which is greater than 1, but less than 2. Just go to set b equal to 2, and then here we go. X is greater than 1, but less than 2, which makes sense because if x was any less than 1, the first part would become complex, and if it was any greater than 2, the second part would become complex. This means that the only values of x that are real are between 1 and 2. Let's have a look at something more interesting. Perhaps x squared. In fact, we could take any function of x, or even y for that matter, and multiply by these boundaries, because when it does become real, it's still only 1 and doesn't affect the shape of our curve. Let's have a look at some values. Let's say minus 1 and 1. This hides our parabola for all values less than minus 1 or greater than positive 1, which gives us a friendly looking smiley face. Let's see if I can add in a couple of eyes to this. Let's see, hang on, and get the offset. There we go, and the other one. Here we go. Alright, here's our little smiley face. It may not be the Batman curve, but it's still fairly impressive. And I'm sure that you can see how you might go about making something like the Batman curve by hiding different parts of curves. If you think of something really cool for me to graph, stick it in a comment below and I'll have a go at it in another video. And if you like more mad maths like this, then subscribe and maybe check out some of my other videos. That's it for now, and thanks for watching.